like this. And I think it's called the flux of a vector field F over a surface S. Or essentially, find that guy. Now, it is a double integral. It is over a surface, so it's a surface integral. It is a little bit different in the way that it is calculated. As I said earlier, it's something to do with physics. Do not know what it is, but it is something to do with physics. It is equal to the double integral over d, which we are comfortable with, a guy I'm going to call negative p negative qr dot dz by dx, dz by dy, comma, dz by dz, dA. So essentially, this thing turns into a dot product with the dA representing either dx dy or polar. So we need some details, some flesh on this. Can you imagine that you have a vector field and it's called, what have I called it? 2x, comma, 2y, comma, xz. The guy that's called P is this fella, the guy that's called Q is this guy, and the guy that's called R is that guy. Okay. And the surface S is being described by Z equals 2 take away x squared, take away y squared. And in this case, and in fact, in many of the cases, we don't really worry about what D looks like because they'll tell you. Right, so it's a little bit easier. You know, a lot of questions, they tell you the surface and then you have to project it down onto the ground and then you have to figure out what the limits of integration that would generate D look like. Right, and can you see in this case, it's a little bit easier, at least in this question, that you're given D. So these features are all going to go in here, right, using these data points. So P, Q, and R are these guys. Z is this fella. So when they talk about dz by dx, they mean negative 2x. When they talk about dz by dy, they mean negative 2y. And when they talk about dz by dz, I'm really being lazy here. It's actually 1 all the time. But, you know, dz by dz, it kind of has a flow to it, doesn't it? It kind of makes sense. So you want to put this together and calculate the flux. So it's going to be the double integral over the region D, negative P, so you take this guy and stick a negative in front of it, negative Q, you take this guy and stick a negative in front of it, and R, you don't do anything to it. Dot product with this fella, this fella, this fella. So negative 2x, negative 2y, 1 dA. It's a bit like just following the instructions, right? Are you happy about I'm following the instructions according to the formula? Now in this case, the integral, or the double integral over D is the dot product. So this guy times this guy, which is negative 2x times negative 2x, plus negative 2y times negative 2y, plus, I guess, xz times 1 dA. In this case, I have 4x squared, 4y squared. Technically, I have xz right now. And I'm definitely putting in a lot more lines of working than you would ever want to, unless it was maybe a test. Four x squared is good. 4y squared is good. I have a little bit of a problem. I have an xz. Okay, I need everything to be in x's and y's, right? So I can't leave it as x, z. So somewhere in here, there's a piece of information I'm going to use to replace the z by x's and y's. Can you see where it is? Because it is on the screen in front of you.
Yeah, what the surface is defined as?
Right. Yeah. So z is going to be this guy. So this guy is going to be x times, take away this guy, dA. So we've got a double integral over d of 4x squared plus 4y squared plus a 2x, take away a 2x, take away an x cubed, take away an xy squared dA. Now, it might look messy, and certainly it is messy, but it's now doable, isn't it? Because we already know who d is. It was given to us in the question, right? It's the integral from y equals 0 to y equals 3. The integral, say, from x equals 0 to x equals 2. That horrible mess, which I'm not going to write again, dx, dy. Isn't that just a big, long, ugly double integral?
It's long and it's annoying, but it's doable.
Right. And you know, you just be careful and you'll be fine. So this new fella, this thing called a flux. I know I've read it somewhere. I'm not that interested in it, but I think. Oh, darn it, it's gone. I was going to say it's something to do with, doesn't flux get involved in magnetism somewhere? I'm drifting a little bit, but so I can get it out of my head. Has anybody heard the term flux used in electricity or magnetism? Mostly magnets. Magnets. Right. So it's something to do with the magnetic fields working on a surface, I'm assuming. So it's a bit, I know, it's like finding the total magnetic effect or something, right?
Yeah, I think it was like the interaction between the magnetic field and whatever surface it's crossing through.
Right. So it's, what you end up with is a number that in some way measures something passing through a magnetic field, a surface passing through a magnetic field, probably.
Isn't it the total net flux, like the total, like n minus out, and then that number is just the magnitude of what results?
I'm glad you know what the heck that is.
That's
so the bottom line, as far as I'm concerned, is that this is how you do it mathematically. The bottom line for some of you engineers is, oh, now I know a number that I wanted to know, right? And it has something to do with magnetism and things going in and things going out, evidently. Yeah. Are we cool with that, or do you want to see another one of these guys work through?
I'm cool with that one.
This one's good. Do you want to see another one of these, or is a one enough to give you a flavour of how it's working?
Perhaps one where we have to find the boundaries for x and y.
Okay, let's see if I can find one that does exactly that. Okay, so in this particular one, we're being asked to find the flux over the surface S of a vector field F. The information that we're going to be using in this case is vectors. I think it's X, Y, and Z cubed. Can't read my own writing there. So that's going to be our kind of EQR fella. That actually doesn't matter too much because you end up with just ugly polynomials. So I could have made that x squared and made that minus z squared. It wouldn't really matter to the process. So I guess I'm not worried if I didn't quite get that in detail. The S, however, is the thing that we wanted to do, something where you actually need to find D, right? So S is described as a cone with formula square root of x squared plus y squared. And it's between z equals 1 and z equals 6. Now, if you take a cone, which is basically that guy, and you cut it at z equals 1, you'll end up with a circle, right? And then if you cut it at z equals 6, you'll end up with a different circle. And it's the bit between those two, if you can project them downwards. Can you imagine one is a hole cut out of the other? So it's a torus or an anus. I guess a torus is a 3D anus, but it's a donut. I like the term donut bear, right? So that's the guy. That's the guy on the floor, actually. That's more what it would look like, right? It'd be symmetric around the origin. Right? So this is D. And I'm told Z equals x squared plus y squared, and we have this guy and this guy. This shape is floating above the surface, and then later on we're projecting it downwards. So that makes it a little bit different. But if you take Z equals 1, can you see that you get the first circle? And then if you make Z equals 6, you get the second circle. So this fella here is made up of a circle radius 1, radius 6. Does that make sense?
Yeah.
Now,
Alternatively, you could also just turn the x squared plus y squared into r squared, and that gets you r.
Oh God, yes, that's exactly where I'm going to go. You're ahead of me, but that's good. When I look at D and I see a circle, half a circle, a donut, would you agree that the polar form is the way to go? So I'm going to do not x and y, dx, dy stuff, right? I'm going to do r and theta kind of stuff, right? So D is going to be described in terms of polar. And in terms of polar, it's pretty easy to describe it, isn't it? Oops. Isn't r going to go between 1 and 6? And won't theta be, I believe, the whole shape? Right. So we've got this weird surface of a cone, right? It's basically a big circle with a little circle underneath it, right? And if you project it down, and can you imagine this isn't the whole cone, it's just the outside of the cone. So you splice it and you splice it, and that's where the donut shape comes from. That's this fella. Now I still need to do my calculation with my formula, and I'm still going to do all that dz by dx stuff. But once I'm finished, won't I turn all the x's and y's into r's and thetas? Because this region here is kind of screaming out do polar. So let's see what we get when we try that out. So the flux guy is going to be the double integral of negative p, negative q, and r, followed by dz by dx, dz by dy, dz by dz dot dA, right? So that's going to be a double integral over d. Negative this guy, and leave the last guy alone. Dot product. Yikes, I wish I'd thought this one through before I picked it. Don't I need to differentiate this with x, differentiate this guy with y, and differentiate this guy with z? Agreed? You know that's not going to be pretty. Agreed? Right. Can I at least get away with some symmetry? So this guy's 1. That's the only easy one. Right. If you take this guy and you differentiate it, I'm going to stick in a little bubble over here. Hopefully I've got enough room for it. It's going to be x squared plus y squared to the half. Its partial derivative with respect to x then is going to be 1/2 x squared plus y squared to the negative 1/2 times 2x. which is eventually going to get me x over the square root of x squared plus y squared. So I'm going to have an x over the square root of x squared plus y squared, comma, y over x squared plus y squared as well, comma 1. Are we okay with that? You know how easy it is for me to screw up? Okay. Now you do the next bit and you're going to get that times that, which is negative x squared. That times that, which is negative y squared. That guy is over this fella. Take away that guy is over this fella. And finishing with a z cubed dA. Interesting. If I combine these two guys together, can I get a single one of these over one of these? You happy with that? That a negative x and a negative y squared gets me negative x squared plus y squared, and they both share a common denominator. On the other hand, won't z cubed just be this guy up here cubed? Right, z cubed is this z here cubed. So that's going to be the square root of x squared plus y squared cubed dA. Okay, I think I've reached the point now where everybody could probably be turned into r's and thetas, right? So the integral is going to be r equals 1 to 6, theta equals 0 to 2 pi. All right, let's see what each of these bits are. What's x squared plus y squared going to be?
R squared.
Right, and then isn't the square root of that r? So won't this divided by this just give you negative r? You happy with that? Have I done too much or you go? R squared over r cancels down to r, stick a minus in front of it.
Makes sense.
Won't this be r, so you get r cubed? So that came out nice. R, dr, d theta. Actually, I should probably switch the order, but not really that big a deal. If I split these up, you can do the integral from 1 to 6 of negative r squared plus r to the 4 dr times the integral from 0 to 2 pi of 1 d theta, and we're pretty much done. Right. So the clues here that polar was the way to go. I think it's not so much a clue, it's a kind of, I'm not going to do that with x's and y's. Can you just look at that and you're thinking, ain't going to happen. And if it ain't x's and y's, it's polar, right? I mean, you only have two, typically you only have two directions to go.
Especially if you have a bunch of x squareds plus y squareds.
Yeah, they're almost always r's, aren't they? And things with r's, r squareds, right? And if you get an odd x left over, can't you just call that r cos theta and live with it? It's not that hard to deal with. We cool? So anything involving circles, especially if D is involving circles, or anything that has integrals with lots of x squareds and y squareds, are probably going to be polar. But you know the x cubed plus 5y squared minus 42x, those kind of guys, where the region is just some, I don't know, square or rectangle, which is what they typically are anyway. And you know that's going to go dx and dy, isn't it? Now, the next bit I'm not going to help you with, not because I don't want to, because I'm kind of unclear. And I think it's to do with the physics of the thing, but I'm going to blame the book. They have a thing called positive orientation and negative orientation. And evidently, when it's negative orientation, you stick a big negative in the front of all of this. So if your answer's 42, it becomes negative 42. And if it's the other one, it's 42. So unless the book is clearer, or at least my brain is clearer, I'm not quite sure how you can tell if something's positive orientation or negative orientation when it's a surface. I know how to do it when it's a loop. You know, if you go anti-clockwise, it's positive. If you go clockwise, it's negative orientation, right? But if someone could refresh me or tell me how physics people know that a surface is positive orientation or it's negative orientation, I don't know. Is the short answer. It might mean, however, that you get the right answer but the wrong sign. So if you're doing one of these questions and the first time you do 42 and it says wrong, will you try negative 42 before you try anything else? Just in case that's the only problem.
Yeah, I noticed on the homework it usually said whenever it had the thing saying is upward, that was positive, and when it was downward, it was negative.
But no indication of what upwards means. Well, I guess upwards means positive Zs.
Yeah.
Was it as simple as that? Did it always work out okay as long as you followed that rule?
Yeah, so long as you follow the rule where it says
Up is positive and down is negative.
I'm trying to find one on the chapter 16 homework.
Okay. While you're doing that, no, you can find one, that's fine. I was going to look up, but it would take me too much time. Are we good with the flux, or do you want a third one?
I just want to clarify. So the only difference with this equation is the negative P and the negative Q from what we were doing. Finding,
Yeah, the negative P and negative Q is part of this weird flux calculation. So that's
Okay.
the major difference. So you're talking about the dot product thing?
yeah, with the
Yes.
surface integral.
Yes.
Okay, and I did find one.
Okay. And does it say plus and minus or something in orientation?
Yeah, it says where it says like S is part of the paraboloid, Z equals whatever, and above square or circle whatever.
Okay.
And at the end, it tacks on and has an upward orientation or downward orientation.
Okay, so upward means I'm assuming positive orientation,
Yes.
and downwards means negative. Now, your question was basically the only difference is there's a negative P and Q. I'm sure there's a theory behind it, and some really clever guy figured out that that's what you need. I can't explain. It's not my thing. Why that's there? Isn't it just like, trust me, I'm a mathematician, and move on with your life? We'll just call it that. Okay, last chance. If you want to, I'll do one more of these. Otherwise, we should probably move on to something else that might be causing you some issues, and you want to at least get a shot at me doing it for you. I'm assuming then that we are good. I'm going to zoom out here for a few seconds.
I had a question on one of the chapter 16 review.
Okay, hold that thought. I'm going to go straight there. What question was it?
For me, it's question 24, 16.7.003.
Right, 16, 20. I don't have a 24 and 16. Is that? Are you sure?
It's a chapter 16 review.
Right.
Question
24. I am chapter 16 review. In my one, I've only got 22 questions. Maybe it's question 22 then. Is it a x squared z, y, z, ds?
I have 25 questions here.
Yeah, I have 25. Sorry, yeah, 25. So I have it. That's weird.
So it's 24 then. 16.
Okay, it's 24. Let the hemisphere x squared plus y squared plus z squared one.
Yeah.
Okay, and suppose that f is a continuous function, and they tell you some start values all the way along. Oh God, not the 4 one. Yeah. Okay. No, we're not doing that one. Yeah. Okay, we are not doing that question. It's a 4-patch one, and it basically is a numerical technique that we haven't even covered. So I apologize. I think when I put it in, I thought it was a different question. I'll double check that I'm actually telling the truth here.
Which question was it?
It's 24. No, see, I've only got 21 questions here. I'm sure I took that guy out.
I
have 25 in the last, 23 is also one of those ones that like is just killer.
Yeah, okay, I don't know what's happened here because I definitely changed some questions. Okay, I'll show you what I can see and then we'll try and figure out what the heck is going on here.
All right.
Right, so
There might be a couple questions that you removed that haven't updated yet.
oh god, that could be it. I apologize if that happened. Okay. I'm looking at the question browser. That should be good enough. Okay, so make sure I'm not looking at the test. No, I'm not. Okay. So I'm going to go in. I'm going to share that page, and then we can still, this one here. Right, are you all looking at this fella here? Right. So
Yep.
I have 25 questions. I'll click on this one. It looks like this. I'll click on the one before it. That's the one, isn't it?
That's the one.
Yeah. And he's still there. Right, now if I click out of that, and then I go in and I just do view mode, is he still there? See, he's not. See, I only have 22. Can you see view mode?
It's loading for me. It hasn't showed up on screen
Right,
yet.
okay, I have to go out and then. You see, in view mode, I only have 22
There it is.
questions.
You see the bar?
Yeah, can you see
You
the bar? It
scroll?
goes,
Yeah. You see the scroll bar on the bottom?
yes.
Scroll it over.
Oh, darn it, they are there.
There you go.
It didn't update. I thought when I saw 22 that I'd taken the question out and it was just hidden.
It only shows up to 22 questions on there when you don't have anything done. But
right.
if there's more, you just got to scroll it.
Okay. That was question probably 24, this thing here. Just to show you before I make it go away, let's just show you what the solution looks like. Very cryptic. It says we can use the XZ and the YZ planes to divide H into 4 patches of equal size, which means you only need to find one of them essentially, and that's 1/8 of the surface area of the sphere, and that's the radius, and then they're doing it as a numerical. ds or delta S is given by this fella. Basically the radius squared, 1/8 of 4 pi radius squared. That's this guy. And then they choose these as sample points and they do the whole thing. When you look through this, it's actually a lot more cryptic than it is. You're being numerically estimating a double integral. So
I don't know
for
about anyone else, but I can't see that.
oh,
And it
I'm
did the
not
same
going
thing.
back in and out again. Well, we just take it that that question should never have been there, and I thought I'd killed it. And because I went and looked at view and it only said 22, I mistakenly thought I had killed it. The short answer is I'm not going to do that question at all because you shouldn't have asked you it in the first place. So do we have a question that I have asked you that I should have asked you? Is there anything in curl and div that's causing issues? Any homework question or topic that looked weird?
Curl and div is pretty straightforward, really.
It's plug and chug, isn't it, for the most part?
Pretty much.
Okay. Is there anything in Green's theorem that was causing us any grief?
Yeah, I had a question on number 3 in the review.
Okay. And that one's definitely there because 3 is in the picture. Right. So first I'll find it and then we'll scoot back to it. There's 3. My version of C is joining some line segments together. Is that yours?
Yep. Oh, that one was a fun one. Trying to figure out where it went wrong.
Oh, did you find out?
Yep, I figured it out.
Okay. So I'm just writing the question down here. This is question 3. We have a single line integral from x plus 6y. It's a dx plus an x squared dy. And it goes from 0, 0, at least the one I've got, 0, 0 to 6, 1. And then from 6, 1 270.
Yeah, I guess a main question
Mhm.
is this, was that supposed to be Green's theorem or,
No, you can actually, the way I'm going to do that one is parametric.
oh, okay.
Is that how you were
I think
thinking
this one
of
was
doing
just line integrals.
it? It's just a normal line integral. You could certainly do it. Do you want to see it both ways?
Yes, please.
Okay, so let's tackle it with, for want of a better word, the way my brain would probably work on this thing is
And yeah, Green's theorem actually doesn't work on it.
it doesn't. Interesting. 0, 0 goes here, and then you go 6, 1, which I guess I'll call A, and then you go where do you go? 6, 1, 2,
7, 0.
7, 0. Okay, you go down there. A bit confused. Right. So it's basically a triangular region, isn't it? Are you sure Green's theorem doesn't work on this?
Pretty sure, because it fairly certain that the derivatives of each separate one does not equal each other.
Okay. So we're going along this road and then we're finishing that road. So it's clearly not a complete circle, which is fine. Actually, see if it went back to the origin, I'd probably end up with a bit of luck getting a conservative field and the answer would be 0. But that's asking too much. So essentially all I need to do is split this into 2 different guys. I'll call it C1 and C2. So if I do the line integral for C1 and then I do the line integral for C2, that will get me the line integral from C. So that's my thought process. So the line integral from C1 is just basically this straight line called C1. Passes through the point 6, 1. What's that going to get me? That's going to get me, what, 1/6x?
Mm-hmm.
Right, now in parametric form, couldn't I call x equals t and y equals 1/6 t? Would that be okay?
Yep.
The line y equals 1/6 x is x equals t, y equals 60. That's how you do all straight lines. Make x equals t and figure out where the other guy is. Now, in this particular case, won't t go from 0 to 6? Agreed? Now, if x is equal to t, won't dx be equal to dt? And if y is a 6t, won't dy be 1/6 dt? Are you okay with me doing that pretty quickly without going through all the steps? So I got all the pieces of the puzzle. Let's do the integral over C1. It's going to be x plus 6y dx plus x squared dy. So here goes. It's going to be the integral from 0 to 6, because that's t. The x is going to be replaced by a t. The 6y is going to be replaced by 6 times 1/6 t. And the dx is going to be replaced by a dt. Plus an x squared is going to be replaced by a t squared. And the dy is going to be replaced by a 6 dt. So the surface integral C1 of all that stuff is going to be the integral from 0 to 6 of a t plus a t plus 1/6 t squared dt. And then, can I just say dot, dot, dot to that? Because it's pretty easy to do. Then we'll do the C2 fill in next. Now the C2 is basically this line here. Right? A little bit harder to get its equation. What do I know about it? I know it passes through the point 6, 1, and then it goes to the point 7, 0. So that's 1, and what's that? That's 6. So I know that it is going to have a sloping negative 1/6. And if I plug in, say x is 6 here, if I add 2, then I get it to work. So after a little bit of work, that straight line ends up being negative 1/6x plus 2. Which means,
Isn't it just
Does it?
-1 x?
Oh, this one here?
Yeah.
Yeah.
Plus 7?
Yeah. Good, thank you. I know, I was thinking, who knows what I was thinking. The slope is -1. And then you can plug that guy in and you need to get 7 to make it work. So there's that guy. So x is going to equal t and y is going to equal -t plus 7. So dx is going to be dt and dy is going to be -dt. And the t's are going to go from 6 to 7. So that's from 6 to 7. Instead of x add 6y, I'm going to have t add 6 lots of this fella. And then instead of a dx, I'm just going to have a dt. And then the second fella is x squared, which is t squared, times a dy, which is basically just negative dt. So I'm going to have the integral from 6 to 7 of t take away 36. What the heck's going on here? Oh, that's a t. That's it. Can read them on right. So it's going to be -6t plus 42 take away a t squared dt. So it's going to be an integral from 6 to 7 of -5t plus a 42 take away a t squared dt. And at this point I'll dot it, and those two things would get me the answer. Right, now, I've been told that Green's theorem doesn't work. Is that what you said? Well, I think it should.
Well, Green's
I'll
theorem is
try
only
it
for
anyway.
if you have a closed system.
Oh, of course, it doesn't come back to home. Yeah. So there is only one version of that question. This one. If it did come back to home, it would be nice if it was conservative and come back to home, in which case I wouldn't do anything. I would just say 0. You know, a closed loop on a single line integral that's a conservative field. But it's pretty obvious that those two wouldn't be conservative. So, yeah. That question's quite early on. Didn't they do some questions where they got you to do it with one method and they got you to do it with the other method? I wonder if it's a leftover from that idea where they're just giving you a question. Use Green's theorem or do it some other way kind of thing. My memory served me right, or am I just thinking something's there that's not? Anyway, that's how you would do that particular question. If it had been looked back, yeah, if this question had been looked back, in which case this question would be even harder to do, because wouldn't we also have to find a third curve, C3, to come back home with?
Yep.
And then I would have had a closed loop. If I had a closed loop, God forbid, this would be D, right? This would be a region, right? When I have to split this region into 2 distinct parts, so even that would require 2 separate integrals. All in all, that question could have been even worse than it ended up being. So I'm glad they didn't close it back up. It would have been a real stinker of a question. And that's pretty much all we have time for. This thing is going to be put online, and but not for quite a long time. So you might not even get it tonight, because I need food, and me and my wife are going to go out on a date. So I'm looking forward to that. And so maybe tomorrow would be more realistic, right?
That's
So
right.
you
I think
get-
the other point I was trying to make was that the question itself is not a conservative.
Oh, it's not. Yeah, I'm not surprised. I'm just looking at these guys and I'm saying, yeah, you know, when it's conservative, there's a kind of pseudo symmetry about the things. They kind of look like they're going to, you know, work together in some kind of way. You know, if that was sine x and that was x cubed they never work, right? They're never going to play well together. The first guy derivative with X, the second guy derivative with Y, they've got to end up being virtually the same as each other except for signs. You need a lot of symmetry in a function for that to be true. So you can sometimes just look at something and know it's not going to happen. I mean, that 6 pretty much kills it. Wouldn't you need some kind of 6 over here unless that was a 0 term? And I don't see that happening. Okay, any general questions about whatever's happening or whatever's not happening? Are we good? Are we looking forward to this test?
As much as one
Yeah,
can.
okay then. Are we looking forward to this test being over?
Yes.
Okay, that one I think I could get a yes out of. That's fine. Usual, if you have any last minute issues, darn it, I've forgotten that number again, and I'm going to go out right now and kill it so nobody else ends up trying to do it. Was
Number
it
24?
25? 24? 24. So I'm going to go and kill 24. While I'm at it, was there anything else in that list that is obviously weird? That shouldn't be
23.
there? Is 23 in the same world?
23 was the one that has the 4 different ones.
Yeah, okay, I'll take that one out as well, just to save some grief, because you were never getting it in the test anyway. So 23 and 24 from the review are now going to be gone in a matter of 5 minutes from now. Okay, apart from that, bye-bye, everyone.
Bye.
Thank you.
I had a quick question about this exam. Earlier in the quarter, you said something about the 4th test being like there's something special about it, the way it was graded, or?
No, the finals might be different, but not the 4th test. There's also going to be a replacement test for any of you who want to have a shot at changing one of your tests to a better score. But that will happen in week 10. That might be what you're thinking about.
I'll take that one, thank you.
Right. So we got 23 and 24, just because I'm easily distracted and writing it down, so I won't. Any other questions before I go?
Good.
We're good. Have a nice weekend, everyone.
You too.
Hey.
Bye.
Bye-bye.